I'll get this up so it's not. So good evening and welcome to the end of the fall 2017 term TWed Lightning Talks. Thank you all for, I assume everybody is on. Is everybody up here? Is everybody signed for a spot? This is a fun time. It's an opportunity for each of you to talk for 2 minutes about hopefully your research or some topic of interest to you, and preferably no notes. Just get up here and talk. And because we usually have a full schedule, let's get started. Just a couple things. We're being streamed live, as you know. There's actually 2 or we're not sure, possibly 3 people who will be going in remotely. When it's their time, we'll unmute them and we'll, if they expose their video, we'll throw them up on the screen. Okay. So you're first, man. Okay. Thank you very much.
Good evening, everyone. My name is Tong Tao Zhang, and I'm the 4th year PhD student from Professor Heng Ji's group. This year, I'm working on imitation learning on event extraction. So I know everyone might see a lot of reports about like AlphaGo, and recently we have like we see AlphaZero, which plays a lot of chess games around the world. So I am applying the similar framework to another game, which is called event extraction. So it is extract events from the natural language sentences. For example, who is attacking who in a certain place, or who transfer how much money to another person at which bank. So that is my current focus. And in the future, for my thesis topic, I hope to also include some multimedia, like image or video information, into the event extraction framework. Okay, that's all. Thank you.
All right, thank you. Only other rule, we don't have many rules, but now you got applause for yours. You applaud enthusiastically for everybody else. Okay, so let's hear it for Tom. All right. Thank you very much. And that was 1 minute.
Oh, sorry.
Hi everyone, I'm Sabir Rashid. I'll give a quick lightning talk on
So I'm
generating.
going to do what I always do when I show up to these. I'm standing here in the back of the room. I can't hear a word you're saying, Sabir.
All right.
You have to talk as loud as I'm talking now in this room.
All right.
Very noisy room. That's not a.
Okay. So hi, I'm Sabir Rashid. I'll give a quick talk on generating knowledge graphs as nanopublications. So what is a nanopublication? A nanopub is essentially a named graph which has a few pieces to it. It has the assertion piece, which are the facts in the graph, and then you have a provenance piece which tells you how those facts were generated, and then you can have a publication info piece which tells you how that nanopub was generated, and kind of a piece that says, oh, do we believe these facts or not? So that's what a nanopub is. So how do we generate knowledge graphs? So we're using a semantic annotation method called the semantic data dictionary specification. So we use that to describe pretty much structured data, and then use that to generate a RDF knowledge graph. So how do you generate knowledge graphs as nanopublications? Well, when you're generating the knowledge graph through the SDD spec, if you capture this provenance info or publication info and create these named graphs when you're generating the knowledge graph, then you pretty much generated a nanopublication.
Thank you very much. There you go.
All right. Professor Hendler, can you hear me if I talk like this?
Yeah.
Okay, cool. I'm Katie Chastain. I'm a PhD student with Dr. McGinnis, and to sort of continue on what Sabir was talking about with semantic data dictionaries, we use those to describe implicit entities in tabular data files. That is, if you have a column in your file labeled subject ID and you know it refers to a person, obviously that's obvious to us humans, but not so much to the computer. The semantic data dictionary allows us to say explicitly, this column represents a human, and the number in this column is their identifier. And so I'm working with the human aware sensor. Oh my gosh, I'm so bad. I forgot the acronym, but HUD attack. Data acquisition framework. There we go. Yeah. It's a tool for transforming and managing tabular data as linked data, and I'm working on the process of leveraging the semantic data dictionary to sort of automatically extract those implicit objects that we describe in the data files as we pass them in. So I'm sort of adding on to the functionality of HUD attack in this way to hopefully make it more useful to more projects. So that's what I've been working on this semester.
All right, Dave. You almost had a heart attack there.
Yeah. I like head down, like working on it all the time. I'm like, what does it stand for again?
Hi, I'm Robin. I'm fifth year PhD student working with Professor McGinnis. So my proposal topic will be about the ontology integration and enrichment using the word and text knowledge. So as we all know nowadays, one of the challenges of using ontology is the majority of people use it as a taxonomy because it usually only contains entities which explain the entity-entity relation. Actually, and one of the challenges to write it or build an ontology is because it is highly dependent on the knowledge from domain experts, and not everyone is capable of writing a domain-specific ontology, which will result in when we actually need an ontology for a specific project purpose, then we will find the ontology either be incomplete or missing some certain part of knowledge, either it does not contain like very in detailed domain range and constraints. So what I do is now I have a incomplete but expanding list of the text annotation, which is the text resource as a knowledge external knowledge resource to the many classes and predicates, which is equivalent to schema.org, either as a like in the form of external link to Wikipedia page or some other documents. So in this way, we can treat the ontology structure from a tight structure to a more free and loose structure in the form of natural language and web text. So in this way, we will be able to get more fruit and meat from the text by learning the correlation between these text corpus rather than just using the very limited resources from the ontology comment and the label itself. So everyone is welcome to use my resources as well, and I'm looking forward to expand it using more and including more and more domain-specific predicates and classes in the future. And it can be eventually be a very useful resource for everyone who doing the training task. Thank you.
Hi, everyone. My name is Matt Kawan. I'm a fourth-year PhD student working with Professor Jim Hendler. The thesis topic that I am currently working on is titled Bridging the Gap Between Perception and Reasoning in Computer Vision. So just to give some background, accompanied with the rise of deep learning over the past 10 years, I suppose, is an increase in performance in computer vision tasks like object recognition, and you'll see the results of this in everyday products. It's being deployed. You can go to Google image search and it will help tag objects that appear in images, and you'll go to Facebook and it's getting better at recognizing faces. But one area in which these advances are lagging behind is the ability to use these outputs from these deep learning systems in a more sophisticated way than just recognizing objects in a scene. So the motivating example that I like to go with in this scenario is if you have a bunch of images of a photo, a deep learning system would be very good at picking out photos that contain the bride, because there are some visual features that are common to brides throughout photos. But if you were to attempt to pick out, you know, a person who has a lesser role in a wedding, such as a mother of the groom, it's much more difficult because there's no commonalities between mother of the grooms across collections of images, right? You would have to you would have to incorporate some external knowledge about what a mother of a groom might be doing at a wedding, who she might be with, in order to accurately, you know, pick out the images which contain that person, right? So my work is in creating deep learning models that are capable of generating representations that can then be used for a more sophisticated task like that. So the first step of that process is generating what are called scene graphs. A scene graph is a graph corresponding to an image in which nodes in the graph are objects in the image and edges between the nodes are relationships. And you can also throw in attributes of the objects in the image for good measure. And so that's the part of my work that I've completed so far. I developed a novel method for generating these scene graphs. And then in the future, what I would like to also do is come up with a method of incorporating some provenance into these graphs that I'm generating. So right now, these deep models, it can be potentially difficult to trust the predictions that they make because they're black boxes. And I'd like to develop a method of explaining the predictions that a deep model makes in a method that, or in a manner that is symbolic. So it can be incorporated with the graph and understood not only by humans, but also potentially by an autonomous agent that might want to do some reasoning work. So that's my speech.
Try those new Take it away, Ian.
Alrighty. So hello there. My name is Ian Gross. I am a master's student under Professor McGinnis, and we'll be talking about Satoru agents. So Satoru itself is a probabilistic-driven knowledge exploration platform that basically allows you to insert information, do curation on it, and a bunch of other different things. It uses nano publications, which Sabir mentioned a little bit earlier. So the agents part that I'm working on, it is specifically meant for curation of the data itself. You can basically implement a bunch of other tools that you use to curate all your RDFs before and give new meaning to them. So for example, say I have some PubMed document that I've already extracted RDF information from. I can use some NLP tool to basically create new information from that, and I can insert it into a knowledge graph that's managed under Satoru. And then from there, I could even implement a description logic language that I could provide even further information from without having to run the reasoner separately. And then from there, I can take the output of the reasoner and throw that back into my knowledge hub as well. So Satoru provides that general hub and also allows the functionality of all those separate tools that you may want to incorporate as agents. So my goal is to basically implement a similar workflow to what I described before, where I'm taking information extraction tools and comparing them using similar commonalities that you find between similar documents. And yeah, that's my journal thesis work.
Hi, everybody. I'm Amar Vishwanathan. I'm working with Professor Hendler, and I'm going to add on to the work that I did on query reformulation. Essentially, the idea is that RDF graphs or knowledge graphs, as they are known today, are very popular, and a lot of people use them. Till date, the best way to utilize or access knowledge in an RDF graph has been through Sparkle. But you know that Sparkle is not very easy for people to learn, and so we developed some techniques on reformulating a query, especially when somebody doesn't understand what knowledge is present in the graph and wants more information, you reformulate the query. But the question is reformulating a query enough? Can we do something more? There are different ways of reformulating an initial query when the user wants more results. One way to say is, okay, let me give you some similar queries. But intuitively, that might seem like a really good solution, but not always, because there are times when you would want to explore the knowledge graph or see what kind of data is present so that you can include different aspects of your initial query. to start up with that, we are introducing the notion of diversity in reformulating knowledge graph queries. And how do you do diversity? Well, you want the query, the initial query that you have, to be both relevant and diverse as well. And for that, I have an optimization framework where I use tuning parameters for relevance and diversity, and we have some results on that. So that's what I'm doing this year, and hope to see how we can evaluate this later. Thank you.
Hi, my name is Spencer Whitehead. I'm a second-year PhD student under Dr. Hong Chi. The project that I'm working on is really video captioning. So generating natural language descriptions of multimedia data is becoming a very popular application, a very popular area. So typically, video captioning systems have focused on simply describing the contents of the video. So for instance, a woman is walking a dog, a man is riding a bike or something like that. And some relatively impressive results have been achieved through those systems. But I want to take this a step further and make these captions a little bit more informative. So I want to incorporate background knowledge that we can gather using information extraction from some sort of related documents, and incorporate that background information into my generated caption. So this type of text generation for multimedia data sees a little bit more of an immediate real world application, where understanding, say, a news video that's live at the scene, you now can contextualize that in the generated caption and give the user a more informative description.
Awesome. All right, so our next is remote. It's Anirudh. Let me foreground him here. Hold on. I got to put you on a big screen. All right, okay. Go for it.
Thanks. Sorry I couldn't be there. I'm running bad fever and my eyes are watering and I don't want to step out into the cold. But hi everyone. My name is Anirudh Prabhu. I'll be talking about deep learning for reasoning in situation calculus. Situation calculus is a logical language for representing dynamic changes in a domain. It was first introduced in 1963 by John McCarthy, and it was revamped in 1991 by Ray Reiter. The state of a domain in situation calculus is represented using three main elements: actions, fluents, and situations. Actions are what make the dynamic world change from one situation to another, and actions are also always performed by an agent. According to John McCarthy, a situation is generally a snapshot of a world at any instance of time. And according to Reiter, it's a finite sequence of actions or a history. We can reason about the information in a domain which consists of actions, fluents, and situations using axioms. A typical use case involves providing an initial state for the world, a list of events and actions occurring, and the axioms for that domain. But writing these axioms require an expert, and even for an expert, it takes a lot of time and effort to encode these axioms, and then for the system to reason based on them. So my research involves using deep learning to help write the axioms for a domain. I plan to use automate the entire pipeline by using event, fact, and relation extraction to convert NLP or raw text, natural language text or raw text to Prolog, arrange these events chronologically, and train a deep learning model to write the axioms for reasoning about the world. Thank you.
All right. Thank you. I just realized we weren't videoing. We were recording, but not videoing. High tech.
Hi, I'm Eric Amherst. I'm, I forget what year, PhD candidate now, I guess, with Professor Handler. I'm studying cognitive science. Specifically, what I'm interested in is cognitive load theory for multimodal data exploration and analytics. What that means, basically, you probably may have heard multimedia data, multimedia cognitive load theory, but specifically looking at new kind of interesting modes of visualization that involve both spatialization on top of the kind of traditional modes of visualization. Working specifically on this thing we call the campfire, or more, we started talking about this thing called CRISP, which is co-radial intersurface projections, basically a way to use cylinders and circles and those sorts of things that can represent different modes of presentation, but don't wind up diffusing focus. One of the main things in cognitive load theory is you are basically leveraging or minimizing certain types of cognitive load and maximizing the scaffolding for learning. So we would apply all those same sorts of things that we do in learning and instructional media design, apply those to data exploration and analytics and visualization. And with the Campfire and CRISP, we're able to kind of form new types of visualizations that hopefully allow better understanding of more complex types of visualizations, things that are very complex graphs or very highly dimensional data sets. That's what I'm doing, hopefully.
Right. You're going to have to speak up.
To remember. Hello, everyone. I'm PhD candidate with Professor Handler, and I'm working on noise-tolerant reasoning using deep learning. So as you know, the main focus on reasoning on the semantic web was on the soundness and completeness, and they assume that the input data is true. You don't have noise in your input data, which is not the case in real-world scenarios. Real-world scenarios, either there is noise inherently in your data, or when you are collecting your data using natural language texts and these tools, that there are some classes that were misclassified or something like that, and then you have noise in your input data. When you do use traditional reasonings, that noise will be propagated in the inference. So I've been working on noise-tolerant reasoning using deep learning. So as Matt and Spencer were talking about, in deep learning, there are a lot of success in images recognition using convolutional networks, on text annotations using recurrent neural networks, but there isn't much success on graph when you have graph input. There is few works recently on graphs, but it deals only with homogeneous graphs, where there is only one type of link, which is not the case in RDF, where we have many types of links. So I've been using these techniques, how to use homogeneous work on heterogeneous RDF graphs. So we have a few success on artificial data using LoopM artificial data, where I input some artificial noise, and I have some reasoning that is noise tolerant. And I'm looking to use real world scenarios. So if you have any kind of data that inherently have noise and you want to test it on real world scenarios, I'm happy to discuss with that. Thanks.
Thank you. All right, so our next is Nidhi, who is also remote. Let me just switch her over. All right, Nidhi, you're on. You're on the big screen.
Okay, I can see myself, but I trust you. Hi, everyone. I'm Nidhi Rastogi, PhD candidate working with Dr. Jim Handler. And the topic of my thesis is using information centrality for detecting systemic attacks in large networks. So the problem statement of this thesis is that given the large networks of today, as well as the kind of networks that we'll be seeing in the near future, the amount of data, the network data that gets exchanged can be very difficult to manage, and the removal of noise from useful data can become very challenging. So to identify signals of attacks is what we need to continuously work on to identify basically the attacks of today, as well as cyber attacks that we can expect to see in the near future. So the goal of this research is to propose an intrusion detection methodology that can realign the focus of data collection from important nodes, that can reduce the time taken to detect systemic attacks in a large network. And the methodology that I'm proposing is takes advantage of information centrality, a centrality-based measure in the field of graph analytics, and it uses the topology and as well as a data arrival time to identify influential nodes in a given network. So these nodes are able to see majority of the network flow pass through them, and hence are in a position to utilize, are in a position to also detect network-based attacks much earlier than traditional intrusion detection systems. So the way we proposed our hypothesis is by first, we proved our hypothesis is by first creating a simulated network in NS2, and then by using real data set belonging to configure, a denial of service attack which happened way back in 2009. We compare our approach using state-of-the-art principal component analysis with information gain along with information centrality identified central nodes, and show significant improvement in the time taken to detect network-wide attacks. Thank you.
Right. Thank you.
Hi, I'm Fei Pan. I'm a second year PhD student under Professor Peter Fox, and this semester I'm primarily working on applying machine learning and data analysis methods to mineral data. There's two use cases I'm currently working on. One is to look at the mineral information and chemical composition on the rock on Earth, and we're going to use that data to predict the rocks and their chemical compositions on Mars, and then further understand the living environment and other, probably more information can be discovered on Mars. And the other one is me and Fang, our new postdocs, we are looking at the mineral inclusion in diamonds, and we construct the very first complete data set on mineral inclusions on diamond. Now we're doing some clustering, and we're plotting out the results and seeing some really interesting findings comparing to the ground truth.
Right. You're going to have to verify your results by visiting.
Or by getting diamonds.
I'd like to see that proposal. Brenda. I don't think she's remote. There was no. So, well, it's not one of the remotees who contacted me. Well, we could skip ahead to Cara. Sure, but Brenda probably won't mind you skipping ahead.
This will be good practice for speaking loud.
Yes, Dr. Handler. Hello, my name is Kara Reedy. I'm a third-year student in cognitive science working with Dr. Handler, and my current work is on diploid neural networks. Diploid means that it's a kind of genetic algorithm where rather than having one copy of your genetic material, such as you have in a conventional GA, you actually have two copies which might differ from each other at some places. These differences make it trickier to deal with because you have to figure out how you're going to resolve those differences when you eventually make whatever you're going to make from that genetic material. But it also seems to have some real advantages. We think this not just because diploidy is everywhere in nature, for example, as humans are diploid, but because based on experimental evidence, it also seems to be better at adapting to changing environments, to better for preserving population diversity, and better for solving complex problems than conventional GA. So I've been using a diploid genetic system in order to create cafe neural networks. This is an independent standalone system that grew out of a simulation that I have, which is an agent-based simulation where these genetics provide the kind of brains of the different agents. So I've been working on improving and refining that, and I've also been thinking that I want to use this simulation in order to investigate social phenomena. So it would be nice if I could extend this genetic system that I have in order to encode other traits rather than just doing neural networks with it.
Cool. So now we'll see if Shruti is actually able to speak with us. Shruti, can you actually speak with us now? Can you hear us?
Nice picture one.
Yeah, I know. She might. Well, I'd heard that. Did you say that she's like cheating?
Yeah.
Yeah, I don't know why she.
She just wanted to
Maybe she just wanted to work. Okay. Okay. Did we find Brenda?
Not down there. We said you were.
Okay. Well, is there anybody else who did you want to introduce yourself at least? So you have to look into the projector. Go ahead.
Hi, my name is Nkechinyere Nneka. I'm from Nigeria, hence the really long name. I'm working with Professor Hendler alongside Professor Zaki, and I'm working on the Hills project for the chatbot. I haven't yet decided a thesis for myself because I'm a new PhD student, but I'm more or less interested in the health area, more like protein structure and DNA, and trying to see if we could find relationships or patterns between vaccines and viruses and building large networks. And that's basically what I'm interested in working on.
Very cool. And a great inaugural Lightning Talk.
Kitchen and gift from.
All right. Okay, yeah. She's been listening in. So now, did anybody else, the professors and staff, want to say anything?
Hey everybody, I'm Kathy Fontaine. I'm an adjunct professor here at the ITWS department. I carry coffee and teacups everywhere I go. If you see me without one, you know there's a problem in my life. I am also on the Deep Carbon Observatory project with the data science team that Professor Fox leads. So my research interests are data policy and international policies and the way organizations work. So if you see me going around taking notes as I'm sitting in meetings, it's not necessarily because of what you're saying. It may be because how an interaction is happening. And I want to note that down. But I'm not spying on everybody. Data policy is also a course that I teach every spring. And it's an elective for ITW, or I'm sorry, every fall. And it's an elective for the ITWS folks, sorry, or anybody who wants to take it, but it's in the fall. And in that course, I go over, in this country, what the government is supposed to be doing in order to establish policy. And I say supposed to be, how data policies and other policies actually come about and what the impact of that is down the line. And believe it or not, places like universities are way down the policy line. And then I show everybody how to do a very top level policy analysis and implementation, evaluation, monitoring, doing recommendations. In case at some point in your life you wake up one morning and your boss says, please evaluate this policy for me, you will have seen the steps at least once. That's what I do.
Right.
Thank you.
Would you require Advil?
Oh, yes.
Okay, but we will be having a distinguished speaker series next term on the ethics and policy of data, AI, and
all right.
Okay.
At the RPI level, the ideal level, the tetherless level,
it's actually Hassan that we speaker on campus.
I also do an ethics class for the capstone for Rick Plotko for the US, and that's always fun because I make them actually get up and do stuff. And
everybody
they don't
does something
do
for
stuff.
Rick Plotko.
They don't do stuff normally.
Did you want to say that?
No.
No, you already gave them.
Yeah, I gave it to
That's I could, yeah, I'll say a couple things.
Hi, I'm Deborah McGinnis. I'm one of the 3 Constellation Chair professors here. I just thought I'd mention some of the projects that I'm running. A bunch of them were represented here, but So Katie was doing that work within the context of the Healthy Birth, Growth, and Development Program funded by the Gates Foundation in collaboration with CASE, the Center for Architecture and Sustainable Ecology. We heard from Robin within the context of the CHEER, the Child Health Exposure Analysis Repository project, that's looking at exposure and how children develop well or not so well. We heard Sabir within the context of the HEALS project, the health empowerment through analysis, learning, and semantics. And I lead one of the two prongs of that, and the prong that I lead is the knowledge is medicine piece, for which there'll be a great slide deck tomorrow that we've been working on furiously today. I also lead a project on nanomaterials, basically doing a nanomaterials resource for NSF with a bunch of nanopolymer experts. And there's a project coming online that'll be in momentarily on next generation radio. So the spectrum has been expanded that people commercially have access to. And we'll be encoding the policies and doing the knowledge graph infrastructure for that. There's some other projects that I'm missing. I'm looking at you because there must be more, but that's good for now.
Plus all the other ones.
Yeah, plus all the other ones.
That's right.
Okay.
So So I won't talk about all the different things I'm involved in, but what I will do is talk about a little problem that I've been thinking about. How many of you were at my TWed talk last week? Okay, so during that talk, one of the things I described was the construction of this tensor, this multidimensional matrix, which we've been using in that example as the basis for our analysis for the CBIS project, the CBIS analytics. And I also talked about how we're using that same sort of construct. In fact, we developed that construct for work that we've been doing with Global Foundries. And one of the things that's really kind of bubbling up is how do we describe using provenance each one of those cells, okay? Not only describe what that aggregate in each one of those cells, what that statistic is in each one of those cells, but what is the provenance, meaning the analytic execution that caused that to happen, and then how can we turn that into a kind of a template in order to reconstruct that same sort of data structure from another knowledge graph from another data set. And so it's this interesting idea of here we've got this raw data, we've gone through this process, we've created this very useful information structure, which is useful for answering questions, but we want to reproduce that, template that, almost like a reverse provenance sort of thing. So I'm looking for people that want to wrap their heads around data engineering, knowledge graph engineering, provenance, data analytics, to try to play around with this and come up with something. That's what I wanted to say.
All right, I'll do it. But I'm not going to tell you all my titles or all the things I do, because then I would be out of time already.
We've run out of time.
I'm Jim Handler. But I want to tell you actually things where I'm looking to hire some people. So if you have friends or know other grad students looking, let me know. So one thing we have is probably a master's level project. Eric mentioned the campfire. We'd like somebody to turn that into more of a development platform. We have funding for someone who wants to really not build a demo on that thing, but build something that other people can build demos on them. So that's one. Two is, I had three and now I can't remember. Not funded directly, oh yeah, of course. Not funded directly at the moment, but something which I'm very interested in is, most of you guys have talked about RDF. Some of you know OWL. OWL was designed for reasoning use cases that nobody really cares all that much about, and missed a huge chunk of data-related inferencing and features that everybody cares about now. So I'm looking for some people who are interested in sort of the language design and how we can grow it. So sort of a data owl, as it were, whether it's STOK or data RDF. And so there's definitely interest on that. That has sort of some startup funding to play with, and I'm hoping will develop into a real funded project. And then the third one is, you heard Matt and Bassem talking about the thing I'm really on the kick for these days is how do we take modern AI and old AI and put them together? So it's still the case that all the old stuff is better at long-term reasoning, planning, linking data, that kind of stuff. But we have this whole new stuff that's doing new kinds of language, new kinds of vision, new kinds of, call it inferencing or call it network completion, whatever. And right now they basically don't talk to each other. And the big problem I have on this project is I got two great students who are both graduating, damn it. So, so sort of with Bassem leaving soon and Matt leaving soon after.
I have you on record. You said you were leaving.
Yeah, that's right. I did say leaving. I didn't say leaving with a degree. It is my expectation that they will both be finishing theses sooner than we will have solved this problem with full generality. So I will be looking for someone who's really interested in exploring this stuff further and going on. And we'll probably start that funded through HEALS or some other project. But then I really want to start taking that further. And that may be part of what NECA works and it may be something different. So I'll stop there. And if you know people looking, let me know.
Probably more specific stuff that the campfire.
You have them. I guarantee you have the skills.
I know someone who I'm not sure about the whole stack.
So, so let me not keep everybody busy
Yeah,
for that.
okay.
Let's take you, me, and Eric, and or John can do that real quick in a minute. But mainly, I'm looking for someone who'll be pretty serious programming skills.
Okay.
Okay, that's me.
All right.
Richard, yeah.
None of you have ever seen me before, I'm sure. You've seen me. My name is Richard Stanton. I'm actually on the advisory board of TWS. I was just visiting as a guest of Jim's tonight. I spend my days down in New York City running an innovation lab, as well as a venture capital group, particularly interested in the intersection between human behavior, technology, and what we call disruptions in future business models. So if you're a very large company, the next startup that may disrupt you can be a very scary thing. What we try to do is we try to get ahead of that. We try to look for very little ways in which we can take certain technologies, enrich our own company, and provide that, if you would, hedge and or protection against those future inventions. Some of the stuff that was discussed tonight is stuff that we're looking very heavily at, particularly in the area of authoring programmatic content. The rise of bots being able to actually produce large-scale content is of interest to us. This gentleman spoke about the use of galleries. Galleries is something that we look very carefully at in terms of being able to create narrative associated with those galleries. Most people don't realize, but 80% of page impressions in content sites today are actually taken up by visual galleries and not by narrative content. And that includes Wall Street Journal and other major mainstream publications. So because of that, we're very interested in being able to generate more of those galleries using obviously programmatic means. And that's what I do, and that's who I am.
Awesome. And that was 2 minutes.
That was 2 minutes. I do this a lot.
So give him your business card. So I think that's it. Thank you, everybody. Let's give yourselves a nice round of applause. So we recorded this. Our camera was in and out throughout. So I know we captured all the sound. I know we captured the video of our remotes, but it may have cut out of you. But anyways, this will be posted up in the TWed YouTube channel. And thank you very much, and have a great holiday break. All right.
Oh, and do we have the first one scheduled for next?
No.
No. Okay.
Well, but there is an
Watch
RPI.
this
There
space.
is an RPI, our users group, next week, the end of term spectacular. I haven't decided yet what that means. Right, and let's kill this. Let's see if we do this.